Okay, so we are going to be going over the answers to quiz 8, and we are going over the blue version of the quiz, and at the end you will see the answers to the yellow version of the quiz. So number 1 says that we have a bowl of candy that has 7 different chocolates, 4 different mints, and 6 different caramels. And we want to know how many ways can a sample of 4 be chosen such that there are exactly 3 chocolates or exactly 1 mint. Okay. So remember that OR means we're talking about union, okay? And when we're doing combinations, the union is adding separate events, okay? So we are going to add the event that 3 chocolates is drawn to the event that exactly 1 mint is drawn. So those are 2 separate events that we're adding. So we have the event with 3 chocolates drawn and the event with 1 mint drawn. Now, remember, we're choosing from a sample of 4, okay? So if we draw those 3 chocolates, we also have to have 1 candy drawn that is not a chocolate, alright? If we draw the 1 mint, we have to have 3 other candies drawn that are not mints, okay? Now the other thing you need to think about whenever you're doing union, whenever it says OR and you're adding these separate rectangles, these separate events, you need to ask yourself, can these 2 things occur at the same time? Can I draw 3 chocolates and 1 mint at the same time? And the answer is yes, you can, because you're drawing a sample of 4. And whenever those 2 things can occur at the same time, you need to subtract it, okay? It's just like the rule that we talk about, the union rule, okay? So if you want the number in chocolate union mint, which is what we're doing, 3 chocolates or exactly 1 mint, so their union, you have to add the number of occurrences where you get the 3 chocolates plus the number of occurrences where you get the 1 mint minus their intersection, minus the time that they occur at the same time. So we have to subtract the event that we get those 3 chocolates and the 1 mint at the same time, okay? Because otherwise we're double counting it. So these are my rectangles, these are my events that are occurring. Now I need to find out what is n, what is the number I'm choosing from for each of these occurrences. So if I draw 3 chocolates, how many chocolates do I have to draw from? Well, I have 7. So it's a combination 7 choose 3. Then not chocolates. How many not chocolates do I have? Well, I have 4 mints plus 6 caramels, so that's 10 not chocolates, okay? So there's 10 not chocolates I could choose from, and I want to pick one of them. Then mints, there's 4 mints for us to choose from, and if you add the 7 plus the 6, you will get that there are 13 not mints to choose from. And lastly, in our subtracting our intersection portion, we still have 7 choose 3 for a number of chocolates. There's still 7 chocolates, okay? And we have 4 mints, and we're choosing 1 of those mints. Okay, so now we want to write out our combinations. We have a combination 7 choose 3 times a combination 10 choose 1, and we are adding that to a combination 4 choose 1 times a combination 13 choose 3. Then we're going to subtract the intersection, which is a combination 7 choose 3 times a combination 4 choose 1. And if you want to put each of those into your calculator separately, those are the numbers you get. Now a lot of you got these numbers, but then you just messed up in your adding and your subtracting, and so you got the problem wrong. So the answer you should get is 1,354, okay? That is your answer. Those are the total number of ways that we can get exactly 3 chocolates or exactly 1 mint. Now just so you know, there have been several problems that I have taught you that have been on quizzes and practice problems and so forth that have gone over situations like this. So there's no excuse at this point in time for not understanding how to do this. Number 2. We have 5 different fiction books, 6 different non-fiction books, and 3 different reference books. How many ways can the books be arranged on a shelf if the reference books are kept together? Okay, so the only books that matter that they're together or not is the reference books. So that means these 5 fiction books and 6 nonfiction books can be arranged in any order. It doesn't matter, okay? So there's a total of 11 books when you add those two together, and since it doesn't matter who goes where, the arrangement of those 11 books is 11 factorial, okay? Now, let's think about the 3 reference books. The 3 reference books need to be kept together. So if we want to look at the different locations where we could put those 3 reference books, you can draw it out like this, okay? So all these little lines in between the other books denote a place where we could put our 3 reference books. So there's 1 spot we could put them, 2 spots, spot 3, spot 4, spot 5, and so on, until you count up to 12. So there are 12 total locations where we could choose to put these 3 reference books. Because remember, these 11 other books, it doesn't matter where they are, okay? So there are 12 spots that we could put the 3 reference books. So we have a combination 12 choose 1, which is equal to 12. So pretty much we have 12 spots that we can choose from to put the reference books at, and we're only going to choose 1 spot, okay? Because we're keeping the reference books together as a whole. So we're not going to pick 3 spots, because that would mean we're separating them. We're picking 1 spot for those 3 reference books to go. And that is combination 12 choose 1, and it gives you 12, okay? Now lastly, remember we have 3 different reference books, okay? So if we have 3 different reference books, how can you arrange those 3 books? Well, it's the same thing like we were talking about in the beginning with the 11 other books, okay? That's 3 factorial. There's 3 factorial ways to arrange those reference books. So, if we combine all that together, we have 11 factorial times 3 factorial times 12, or you can just leave it as combination 12 choose 1. And that gives you 2,874,009,600, okay? So this problem is very similar to the one on the review activity where we had to arrange the boys and the girls could not be next to each other, okay? So this problem is very similar to that. Alright, number 3. A cup contains 4 coins, 1 bronze, 1 copper, 1 silver, and 1 gold. A single coin is drawn at random from the cup. From the samples, find the sample space and then determine how many events are possible. Okay, so the sample space is what the outcomes we could get, okay? Since a single coin is drawn, you could either get the bronze coin, or the copper, or the silver, or the gold. So that is our sample space. Those are the total number of outcomes we could get, 4, okay? Since we're only drawing 1 coin. So that's the first answer. Then we want to know how many events are possible. Remember that total events is equal to our total number of subsets, okay? Those words are synonymous with each other. So remember that our formula for subsets was 2 to the n, where n is the number of outcomes in our sample space. So our events is equal to 2 to the n. Now how many outcomes do we have in our sample space? Well, there's 4. The bronze, copper, silver, gold coins, okay? So 2 to the 4th equals 16. So our total events is 16. There's 16 events, okay? Now, a lot of you have been having trouble with this and felt like you weren't given the information, but I will tell you right now that both of these things are talked about in the video that is labeled Language of Probability from the Week 7 videos. It's the very last video on that list, okay? So, I don't know if you're not writing notes down or not paying attention, but it's spelled out for you right there, okay? So I don't want you guys to miss this anymore. Number 4, consider a universal set with A through Z with the subsets A, which contains A, B, C, D, and E, and B, which contains A, E, I, O, and U. Alright. Now, letter A says that the subset containing A is an element of A intersect B. So I just said it. What do those curly brackets mean? Those curly brackets mean that you are talking about a set, okay? And in class, I told you guys this, and it's in your videos too, that if you are using the element symbol, anything that is denoted on the left-hand side is an object, and whatever's denoted on the right-hand side is a set. You're saying that an object is an element of a set, okay? So right here, when we're saying curly bracket A, close curly bracket, we are saying a set is an element of a set, and that is not possible because only an object can be an element of a set. So just because those curly brackets are there, the problem is automatically wrong. I don't even have to look at, A intersect B and see if A is there, because those curly brackets make the statement false. Okay? Now for the second one, we say that the number of elements contained within A union B is 8. Okay? So I'm going to list everything in A and B. And then when I do the union, I'm going to first write everything that was in A. So A, B, C, D, E. And then just to make it easier and to make sure I don't double count, anything that I already have and is also in B, I'm going to cross it out in B so that I don't rewrite it. So I already have A in my set, so I don't need to rewrite it from B. And I already have E in my set, so I don't need to rewrite it. So the only other letters I should add is I, O, and U. And now, how many letters are contained within A union B? There's 8. There's 8 of them. So the answer is true. There is 8 elements in A union B. Okay, moving on. Oh, also, you guys, please note that math is all about rules, okay? And about how these things need to be written in the correct way. Those curly brackets up there make it wrong. Make the statement up there wrong. So you need to take note of these things, okay? And there were several examples of how to do these problems, problems similar to this, in the week 6 activity that we had. Okay, so you should go back and look at that if you don't remember. Number 5, a jeweler wants to make silver and gold rings. Constraints led to a feasible region bounded by these corner points. Okay, so these are our corner points, where X is the number of silver rings and Y is the number of gold rings. Okay, if the profit on the silver rings is $4 each, okay, the profit on the gold rings is $12 each, how many silver and gold rings should be made to maximize profits, and what is the maximum profit? Okay, so the first thing we want to write is our objective function. What is the function that we are trying to maximize? So since X is the number of silver rings and the profit is $4 each, we have 4X, and Y is the number of gold rings and they're $12 each, so we add 12Y, and that gives us our objective function, our profit. Okay? So now I'm going to put that into a table, and I'm going to list all the corner points that we have and find which corner point maximizes our profits. So if I list all my corner points, then I'm going to start plugging them into this objective function. So for the point 0, 0, I get that our profit is 0. For the point 0, 9, I get 108. For the point 6, 7, I also get 108. And for the point 8, 0, I get 32. Okay. So we want the maximum profit, which occurs at 2 points. Okay, our maximum profit is $108, but we see that it is occurring at these 2 points, 0, 9, and 6, 7. Okay, normally we would say that a maximum profit of $108 occurs at infinitely many points along the line 4x plus 12y equals 108 between the x values of 0 and 6, right? At infinitely many points between these two corner points, if we labeled them B and C or something like that, infinitely many points between those 2 points along the line. But in this case, that is not correct, okay? And I want to tell you, the reason it's not correct is because we are dealing with a real life situation, okay? And in real life, you cannot have decimals. So the maximum profit of 108 cannot occur at infinitely many points along this line because that includes decimals, okay? We need to find out which x values between 0 and 6 on the line have whole numbers for their y values, okay? This is simply because if you say that the objective function is maximized at infinitely many points along the line, remember that infinitely many means that we are using decimals, okay? And you can't have a fraction of a ring. It's not possible, okay? So since it's a real life situation, we need to find the whole numbers. So we're going to take our objective function where it's maximized, okay? So that's 4x plus 12y equals 108. And we're going to solve for y. Alright, so I'm going to move over the 4x, then I want to divide by 12, and I get this final function, okay, y equals 9 minus 1/3 x. So what I want you to do is plug this into y equals on your calculator and look at the table, okay? So I'm going to do that right now with you guys. So I'll go to my calculator. Alright, so we're going to go to y equals, and the equation was 9 minus 1/3 x. Okay, I'm going to graph it. Just note that graph doesn't really matter. I'm going to go to table, which is second graph. Okay, and you can see this is one of our points, 0, 9, but if you keep looking, we have decimals, okay? Decimals are not going to work. That's why we can't say infinitely many points, because this would be 1 silver ring and 8.7 gold rings. That doesn't make sense. So we can't just say infinitely many points and be done with it. So let's look if anywhere else on here we encounter a whole number for both x and y. So 3 and 8 is another point where we encounter whole numbers. And then lastly, 6 and 7, which is one of the points we already found, okay? So, those are 3 points. We have the 0, 9, the 6 and 7, and then we also found 3, 8. That will work because they're whole numbers to give us this maximum profit of $108. So the best way to write that in words, because we have to say how many silver and gold rings should be made, is to say 0 silver and 9 gold rings, or 3 silver and 8 gold rings, or 6 silver and 7 gold rings. Okay? So those are the answers to that, and the way that this problem was done can be found in the key from quiz 5. Okay? I tried not to count off a whole bunch of points on y'all's quiz for this originally, so you should have looked at Dr. Epstein's quiz 5 key, and it explained it on that. Okay? These are the answers to quiz 8 from the yellow version of the key if you need those answers. And that's all I have for y'all.